So we're going to look at proportional relationships one more time. So a proportional relationship is any time when two things that you're trying to compare create a straight line and pass through the origin. So graphically, here's your origin right here, and so it could be a straight line like this, it could be a straight line like this, or it could be a nice flat straight line like this. These are all proportional. The green, blue, and black lines are all straight, and they all pass through the origin. So the other way that you can tell whether something's proportional or not is by using a comparison. Usually it's either K, but sometimes con will refer to the constant of proportion using the letter R. But either way, you're going to take your Y value and divide it by X. And for it to be proportional, all instances that you're looking for have to have the same exact K value when you take your Y value and divide it by X. And so what we're going to look at now is how can you take an original relationship and then compare it with other relationships and see if they're proportional to each other or not. So what we're going to look at right here is a problem of a web designer. They charge a client $600 for 12 hours of work. So what they're going to do then is we want to find out first what the proportional constant of proportionality is for the web designer. And so to do that, it doesn't really matter which one you do first, but usually you're going to have your output, which is 600, and then your input of 12 hours. And so this is your Y, this is your X, and so you're going to take your K equals Y over X, and so you take your output of $600 and divide it by the input of 12 hours. So every 12 hours you work, you create $600 of income. And so when you divide those, you find out then that you're going to earn $50 per hour. Now, of course, if you're working on your own, then you have overhead and insurance and all these other things, so it's not really $50 an hour, just to give you a heads up. But you get $50 an hour paid for each hour of work you do for this client designing a website. So now what we want to do then is, which of these other jobs she built out have proportional or have the same working rate of per hour as that one. So basically, all your prices are your Y values, all your hours. And so, last couple problems, we have a parallelogram. So if you don't remember what a parallelogram is, basically it's an object that basically like a square rectangle that has been slanted. This side and this side are the same. This side and this side are the same. And this side and this side are parallel to each other. And this side and this side are parallel to each other. Opposite angles are congruent as well. And so a parallelogram has a base of 6 feet and a height of 10 feet. So first thing we want to do is find out what's the proportionality for this. And so basically you're going to create a constant. In this case, we're going to compare the base and divide it by the height for each one of these. So our constant for this one is just going to be 6 over 10 or 0.6. So we want to see if each of these down here will have that same ratio. So you're going to take the base and divide it by the height. And so which of these have the same proportionality? Well, if you see the word long, that could just be another word for base. And if you see the word high, that's basically another word for height. And so you're going to take your base, 3 over 5, and if you divide that, you get 0.6. So that's a good one to have. Let's do B. You have 1.8 divided by 2.7. Let me take a calculator and do this real fast. 1.8 divided by 2.7. And this one you get 0.666. Basically it repeats. And so 0.666 is not the same as 0.6. And so this is a no-go. All right, next one. We're going to take our base, which is 5.4, and divide it by 9. If you take a calculator, 5.4 divided by 9, you get 0.6. So this one is good. So far A and C are proportional to the 0.6 up here, but this one is not. And so last but not least on this particular problem, you're going to take the base, which is 12.3, and divide it by 20.5. And if you take the calculator, 12.3 and divide it by 20.5, you find 12.3 and divide it by 20.5, you find that it is also 0.6. So that is another good one. So A, C, and D are all proportional to the original parallelogram. B is not. And so that is just one more way to use proportionality of k equals x or y over x, or you can basically create whatever ratio you want as long as it's consistent all the way through all the types of problems, to determine if something is proportional, which means it is similar and it has the same constant rate of change, and it's consistently straight passing through the origin at 0, 0. If you have any questions, you know how to get a hold of me, and have a nice day.